So let's try to sketch functions. So let's try to do that, and let's see how we can do that. Let's imagine a function. So here's our function. It's going to be a very simple function. It's about the cost of tea. So what we have is that x is the number of tea bags, and you can see the number of tea bags are whole numbers, and the price of a tea bag is just $2. So that means if you were to multiply the number of tea bags by 2, you'd get the output y, which is equal to 2x, which would be the price in dollars. Okay, so if you were to buy one tea bag, it would cost you $2. If you were to buy two tea bags, it would cost you $4. If you were to buy three tea bags, it would cost you $6. Okay, so this is very simple. So we can even make a table here. Let me make a small table. So here's y, here's x. If x is 1, y is 2. If x is 2, y is 4. I can extend it a bit just so that we can see. And if x is 3, y is 6, x is 4, y is 8, x is 5, y is 10, and so on and so forth. That's another thing. Now what you have is somebody is trying to buy loose tea also, which means it's just tea leaves. So now what they're going to do is that so x will now be, so x was the number of tea bags. Now here it's just the weight of tea leaves. Okay, now the weight of tea leaves can be any real number, so we're going to import it into the square machine that takes in any real number, although I'm being slightly ignore some details here, and output comes so now what we are saying is that the cost of a tea leaf is 1 gram of tea leaves is $2. Okay, so weight of tea leaves. Okay, so now if you buy 1 gram of tea leaves, you have to pay $2. But you can also buy 1.1 grams of tea leaves, and if you buy 1.1 grams of tea leaves, then you are going to be paying $2.2. Okay, so this is slightly different because now x can be any real number. So let's try. So if x and y, so maybe x, okay, so I should put y above and x below. Let me write y above and x below. So let's say x is maybe 1, then y is 2. But if x is 1.1, then y is 2.2. And if x is maybe square root of 2, then y, which is equal to, remember, square root of 2 is equal to 1.414 dot dot dot, then that would imply that y is equal to 2.828 dot dot dot. So I'm going to write this as, it's going to be a very long number, but it's going to be 2.828 dot dot dot, right? So you see that this can be any real number that you want to. So if you try to sketch this, and I would encourage you to sketch it on your own. So if you try to sketch it, you can see this is I'm going to do for the number of tea bags and the dollars. So what you can actually do is very nicely, you can see that there's going to be a straight line for this one. You can plot it. So this one will be just points. So let me draw the points for you here. So when the number of tea bags is 1, then the cost is 2, and the number of tea bags is 2. So please let me remind you, this is going to be 1, 2, 3, 4, 5. So when there's 1 tea bag, you have to pay $2. When you have 2 tea bags, you have to pay $4. When you have 3 tea bags, you have to pay $6. When you have 4 tea bags, you pay $8. For 5, you pay $10. Okay, so this is how you can graph them on a Cartesian plane. So what we are going to do is we're going to keep this side is going to be y. So I can write y over here, and this is going to be x. And remember, we are trying to get the relationship y is equal to 2x. So y would be kept on the y coordinate and x would be kept on the x coordinate, and that's how we can represent this functional relationship between x and y on a graph. But remember, here in the lower graph, the weight in grams can be anything. Number of tea bags is discrete, so you can either have 1 tea bag or 2 tea bags. Here, the weight in grams can be anything. Let's just start out with something simple. When you have 1 gram of tea leaves, you have to pay $2. For 2 grams, you have to pay $4. For 3 grams, you have to pay $6. For 4 grams, you have to pay $8, and for 5 grams, you have to pay $10. Okay, now you can try to plot intermediate points. Let's say if you pick 0.5, you will find that you have to actually pay $1. And if you pick 1.5, you have to pay $3 because 1.5 times 2 is 3. So if you were to plot this, what you would find is that the plot would look something like this. Okay, and this would be a straight line. Now it's not very obvious it's a straight line, that everything is a straight line. We'll talk about why it's a straight line next time, or maybe the time after this. But remember, there are two important things that I want you to take away from this. Okay, the first thing that I want you to take away from all of this discussion is about functions is, I want to write what I want you to take away. So here are functions. One thing that is important is that functions depend on the type of input. So if you change your input, your function actually changes. Remember that you and your pet giraffe can't shower in the same way. You have to change the machine when your input changes. Okay, that's one thing. The second thing to remember is that same input, same output. Same input implies same output. What do I mean by this? What I mean by this is that whenever you input, let's say, maybe if you input 3 into the machine, you'll always get 6 out. It will never happen that you input 3 into the machine and you get 7 out, because it's a machine that multiplies 3 by 2. Okay? Or if you input square root of 2 into this machine, so if you input square root of 2, the output will always be 2.828 ... right? It will never be that you input square root of 2 and you get a number different from 2.828. Okay, so you may think it's very obvious, but next time we'll see things, machines that don't behave this way. Okay.